The code on carbs. We're going to follow the incredible journey a carbohydrate takes inside your body, from your plate all the way to powering every single cell.
Have you ever really wondered what happens to that piece of bread or that bowl of pasta you just ate? I mean, where does it go? Well, let's dive right in and trace the path of your body's absolute favorite fuel source on a little trip through your very own internal energy factory.
Okay, so first things first, let's meet our main character, the carbohydrate. This is, hands down, the body's primary, go-to source of energy for, well, everything you do. But here's the thing. Not all carbs are created equal. It's a spectrum, really. On one end, you have simple sugars, these monosaccharides like glucose. Think of that as ready-to-use, high-octane fuel. And on the other end, you've got these long, complex chains called polysaccharides. That's the starch you find in things like potatoes and grains.
And believe me, their job goes way, way beyond just a quick energy boost. Carbs are absolutely essential. I mean, they're stored as what's called glycogen for reserve power. They literally form the structural backbone of our DNA. And they're even a key part of our cell membranes, helping our cells talk to each other. Super important stuff.
Okay, so you've taken a bite. The journey to unlock all that amazing energy? It has just begun. First stop, digestion.
The goal here is actually pretty simple. Your body needs to take those big, complex carbs you ate and just break them down. It uses these amazing enzymes that act like tiny molecular scissors. They just snip, snip, snip those long chains into simple sugars, mostly glucose, that are finally small enough for your body to absorb.
And boom, once those simple sugars make it into the bloodstream, that glucose is officially on the clock. It's ready to be delivered like a high-speed courier, dropping off high-octane fuel to every single tissue and organ in your body.
Okay, so the fuel has arrived. Now your body has to make a really important decision. It's standing at a kind of metabolic crossroads. What's it going to do with all this energy?
See, the key thing to get is that metabolism isn't just one thing. It's a balance of two. On one side, you've got catabolism, that's breaking stuff down to get energy right now. On the other side, anabolism, that's building stuff up to store that energy for later. Break down or build up.
So which is it going to be? Energy now or energy later? Well, that choice depends entirely on what your body needs in that exact moment. And there's one key hormone that's in charge of making that call. Let's say your cells are hungry for energy. Maybe you're hitting the gym, going for a run, or even just thinking really hard. They'll use this incredible chemical pathway called glycolysis to instantly split that glucose and release its energy. It's energy on demand. But what if your energy tanks are already full? Well, your body is super smart. It's not going to waste that precious fuel. Through a process called glycogenesis, it does the equivalent of stocking the pantry. It links all those extra glucose molecules together into these dense little packages called glycogen, and then it squirrels them away in your liver and muscles for later.
And the master controller, the traffic cop for this whole operation, that's insulin. The best way to think of it is like a key. When your blood sugar rises after you eat, your pancreas releases insulin. That insulin travels to your cells and literally unlocks the door, allowing glucose to get out of the bloodstream and inside the cell where it can finally be used or stored.
It's a really beautiful, elegant system when it works, but like any complex machine, sometimes things can go wrong, and that can lead to metabolic disorders.
A super common example is lactose intolerance. This is what happens when the body just doesn't produce enough of an enzyme called lactase. Remember those molecular scissors? Well, lactase is the specific pair you need to break down lactose, the sugar found in milk.
And I gotta say, this is a really crucial distinction to make. Lactose intolerance is fundamentally a digestive issue. You're just missing an enzyme. It is completely different from a milk allergy, which is an immune system reaction to milk proteins, and that can be really dangerous. Now, a much more serious breakdown in this system is diabetes mellitus, and it comes in two main forms. In type 1, the body's own immune system attacks and destroys the cells that make insulin. So the key is just gone. In type 2, the body makes insulin, but the cells become resistant to it. It's like the key doesn't fit in the lock properly anymore.
And the scale of this problem is, well, it's staggering. As you can see, type 2 diabetes accounts for over 90% of all cases. And it's so heavily influenced by lifestyle, because factors like excess body fat can basically gum up the works, interfering with cell signaling and making it that much harder for the insulin key to do its job.
So when you step back and look at the big picture, managing your body's energy is this constant, delicate hormonal balancing act. It's all about keeping things in a very narrow, very healthy range.
And the reason this whole system works so well is because for every push, there's a pull. It's like a hormonally yin and yang. If insulin's job is to lower blood sugar, then another hormone, called glucagon, does the exact opposite. When your blood sugar dips too low, glucagon sends a signal to your liver saying, hey, time to break down that stored glycogen and release some glucose.
And that right there is the beautiful harmony of the system. It's this continuous dance. After you eat a meal, insulin levels go up to handle all that incoming fuel. Then, hours later, between meals, glucagon levels rise to tap into your reserves. It's this perfect feedback loop, working 24/7 to keep your blood sugar right where it needs to be.
This whole complex process, from a simple sugar to a cascade of hormones, it's happening inside you right now. It really makes you think, doesn't it? Knowing how your body works to keep this balance, what fuels will you choose for your own incredible energy factory?